Hello and welcome to my SUSECON Digital session about SUSE Enterprise Storage from design to implementation. My name is Martin Weiss. I'm working for consulting at SUSE as a senior architect guy in the infrastructure solutions area. My main topics are software-defined storage with Ceph and SUSE Enterprise Storage. I'm also working in the containers area and doing all the classic SLES stuff. Just as an early heads up, if there are any questions coming up during watching this session, feel free to contact me either online during the Q&A functionality we have in the sessions, or drop me an email, martinweiss@suse.com, and I'm happy to respond. So let's start with an overview about this session. So first of all, I will give a brief introduction about SUSE Enterprise Storage. What is SUSE Enterprise Storage and what can you do with it? Then we talk about the environment analysis you have to do. You have to understand how the environment is looking like, where you're going to deploy this. We're talking about what requirements are important for doing the proper design and architecture for SUSE Enterprise Storage. Then, based on the environment and requirements, we're discussing how to do the proper architecture, planning, sizing for the hardware and the software, etc., that you buy. And then we're talking about deployment best practices and finally about the testing of the system to make sure whatever you implement is really fulfilling your requirements. Let's start with a quick introduction. So basically, you should have heard about SUSE Enterprise Storage already and Ceph before you're watching this session. So I'm not talking about all the details. I'm just explaining you a bit what SUSE Enterprise Storage and Ceph is. So basically, it is a open source, software-defined solution that allows you to build your own storage system. It's based on a scale-out architecture, not a scale-up. Which means you can add additional components while the system is up and running. And while you need more and more performance, you just add more components to the system. You can access the system through multiple different protocols. So we have NFS, SMB, S3, Swift, iSCSI, some native protocols like Rados block device or Liberator access. The whole system is designed for fault tolerance and redundancy. So basically, per design, there is no single point of failure. Regarding storage, we can use replication or erasure coding technology to store the data. We have the system doing self-healing and self-managing. So if you have adjustments, basically the system will automatically adjust itself and heal itself if there are failures. We have included some management and monitoring functionality with Grafana, Prometheus, special dashboard. We have added a very simple and fast deployment method based on Salt called DeepSea. Everything runs basically on all hardware that you can buy that is SUSE Linux Enterprise Server certified. And the whole technology is really, really flexible, which means whatever requirements you have, you can adjust the deployment to your needs already during deployment. Or if your needs change, if your requirements change, you can adjust the system while it's up and running in a total flexible way, most often without having any downtime. So basically, SUSE Enterprise Storage is one base component for BYOS, build your own storage. To set a bit about the expectation, what's possible with SUSE Enterprise Storage and what you can do with it, and how such a system can look like. And because some of the sales folks told me we need some pictures in the slides and show the real thing, I've brought one of the dashboard examples from a cluster that we have built some time ago. And what I wanted to show you here is that it's really possible to get really, really high bandwidth and performance out of such a system. So the system you see here is basically a 104 node cluster. And in this graph, you can see that we have done performance testing. And especially here, when you look at the throughput chart, you can see that we have achieved 50 gigabytes per second while testing against this cluster. And the interesting thing is that's basically a double layer or a double-sided Blu-ray disk per second that we could write to this system. And we have been using, I believe, 10, or if I remember right, there were 10 worker nodes for doing the performance testing. And everything was through S3 traffic. So it was really, really fast. And the other thing I wanted to show here is basically you can see that the cluster shows health okay. So it did some self-healing because you can see that several OSDs, which are basically the object storage daemons, which are the disks underneath, are defect. They are not working. However, the system already fixed itself and went back to a health status okay, and redistributed the data based on the fault tolerance requirement we have specified. So in such a scenario where you have really big storage system with a lot of data, the bigger it is, the more likely is that you have a failure all the time. However, the system will automatically heal itself and just present the administrator that he has to replace some hardware. But from a health status, everything is still okay. One interesting fact here was that even during the initial hardware delivery, I think we got 105 servers, of 104 servers. Already a specific percentage of these servers was dead on arrival. However, we still could deploy the system and use it completely and could fulfill all requirements even though there was part of the hardware broken. So from an expectation point of view, theoretically a lot is possible, but to achieve that you have to have the right hardware, you have to write the right design, the right network, etc. And that is what this session is talking about. So before we do any design of a implementation, we need to understand how does the current environment look like. And in this section, we are talking about the analysis of the current environment. So before we're doing a design, we have to do an analysis about where do we want to place that solution. How is that environment looking like? We have to understand how many locations do we have? Do we have one data center, multiple data centers? Where are servers located? How many servers do we have that will be clients to the system? How many users do we have accessing the system and things like that? We need to understand what other storage systems are there, so probably might need to connect them. We need to understand what is the wide area network infrastructure, especially if we do a stretched deployment later on. What latency, what distances do we have? What bandwidth do we have? We have to understand the local area network infrastructure to figure out what is what fault tolerance do we have, what switches, what bandwidth, what latency, etc. Next level is we have to understand what type of network addressing is used, IP address ranges v4, v6. Do we have proper name resolution? Do we have proper time synchronization? So basically the existing infrastructure might also need some adjustments before we can use or deploy SUSE Enterprise Storage properly. So that's why we need to understand what's there already to figure out what needs to be adjusted. We have to understand, is there any sort of virtualization technology? Do we have VMware? Do we have Hyper-V, etc.? And we have to understand what server hardware is already used in the infrastructure. Where do you get your hardware from? What sizes do you have, etc.? Next step is, because we need to install servers, we have to understand if there is already some sort of a installation framework or configuration management solution available. And last but not least, we have to understand what type of identity stores like Active Directory, LDAP, OpenID, whatever are available. So just in case we need to integrate authentication and authorization to these systems. So after we have done the analysis of the environment, the next step we have to go is we have to understand what are the requirements against this storage system before we can design that properly. And in that area we have two different sets of requirements. First of all, we have the set of generic requirements. So basically we have to figure out what hardware we can use, what are their special hardware requirements, which vendor do you want to have the hardware from. We have a lot of partners that support our technology that also have certified solutions like Supermicro, HPE, Fujitsu, Lenovo, Dell, etc. And the most important thing is whenever we want to build such a software-defined storage solution, we have to have the right hardware. And we as SUSE tell you that you have to use SUSE Linux Enterprise Server certified hardware. So if the hardware you want to use is less certified, basically you can also use it for SUSE Enterprise Storage. And there is one additional certification possible. So if there are some hardware vendors that build appliances, for example, they can also do a full hardware certification for SUSE Enterprise Storage. And that's an additional certification that's optional, that's not really required. But if you can get the hardware with the SES certification, it's even better than just less. So once you have the hardware, the next thing is you need a piece of software for the solution. That just means the SUSE Enterprise Storage subscriptions that we have. And these subscriptions basically include the underlying SLES for the SUSE Enterprise Storage servers and SLE-HA for some use cases to deploy components of SUSE Enterprise Storage in a fault-tolerant way. Once you have hardware and software, you still need one more thing, which is you need to know how to deploy, configure, select the right hardware, etc. So you need some sort of knowledge, and you can get this type of knowledge either by reading our documentation or talking to our sales folks. We have pre- and post-sales consultants which help you for designing and architecting the solution. And we have many partners that can also help you with this knowledge add-on that you need for the complete solution. And these can all help you with building the right architecture, select and buy the right hardware. They can help you with the initial implementation and with upgrades and maintenance of the system. They can give you operational assistance. So once you have deployed the system and hard disks fail, etc., either you can build up the knowledge yourself or you can ask someone to help you. And it also is possible to give you some sort of enablement. We have training, certification, special know-how transfer workshops to give you the right knowledge to deploy and operate the right solution. As part of the software subscription, we also have support included, because once you have the system up and running, you might want to have someone to call if there is some sort of a problem, because storage is really important. And if there is a problem, you might not want to be alone. So that's why we include the 24/7 support already in the SUSE Enterprise subscription. And one more thing we deliver is we give you the option for proactive maintenance for your system through the SUSE Select package, which helps you to do a proactive review of your system on a regular basis, give you assistance during upgrades, review the system, and even on-site visits can be included in different SUSE Select packages. All right, so once you have clarified the solution-related requirements, there are your use case specific requirements that you have to think about. So before we can design the right solution, we need to know what capacity do you need for the system. What initial capacity, what data growth do you expect, how much white space do you want to provide for the system after initial deployment. Then we need to clarify which access protocols do you want to have, because basically that defines what gateways to the system do you need. So Raiders block devices, basically standard block access. We have the S3, iSCSI, Cephfs, NFS or SMB access. Probably you need more or whatever. And we need to know what are the exact requirements for these access protocols, and then we can design the right gateways for the system. We need to clarify what availability requirements do you have. Basically, how many copies of the data do you want to have? Amongst how many data centers do you want to replicate the data? We need to understand how much workload you will have against the system regarding how many clients need how much bandwidth, what are the latency requirements, how much latency can you expect, do you have any special IOPS requirements, and if you have these requirements defined, you also need to specify basically how much read and versus write do you expect against the system. And then obviously we need to know how much budget do you have for the system, because nobody has endless budget. And we always have to balance what we get for the money we invest. Next step is we have to talk about integration and interoperability. So into which other systems do we have to integrate? The identity store, for example. And do we have any interoperability requirements regarding special client operating systems, for example? What clients do you want to connect? Which operating systems do you have against that? Are these supported? Are these tested? Etc. Then we have to think about who are we talking to, because if we are talking to the server people, they might have one set of requirements. If we're talking to the storage people, we might have another set of requirements. So we need to understand who are we talking to and who has which requirements, and basically we might have to balance them, because the server folks might have different requirements than the storage folks. And as you all know, beside the normal requirements, there are also some hidden requirements. So we have to think about, are there any politics, religion, philosophy, or process-related requirements in the company? Because if there are some, we might need to adjust the solution, or the solution might not fit at all. So if we know that, it can help to do the proper design and architecture and do the right investment. Okay, after we know the current situation, after we know what are the requirements, the next step is we take the current situation, we take the requirements, and go into the architecture and planning and sizing exercise, which is, first of all, think about the whole architecture. So in this picture, I just give a brief overview what the standard implementation of SUSE Enterprise Storage, or Ceph, looks like. So on one hand, we have the object storage daemons. Basically, these are the servers having the data in the end. So we have some set of servers that provide the storage capacity and which have the disks. And the more capacity we need, the more performance we need, the more of these object storage daemon servers do we have to deploy. The object storage daemons basically need to be connected to two different networks. So we have the cluster network, which is basically the internal network where just the object storage daemons are talking to each other. And we have the public network, which is basically the network where the native Ceph clients are communicating to the storage daemons. So whenever we deploy SUSE Enterprise Storage, we need two networks. We need the public network and we need the cluster network. And what you can see here is we have the monitoring nodes. These are basically the brain of the cluster. And we have an administration node that's used to deploy and configure the system. Then we have some gateway nodes. Gateway nodes are required for protocol access that's not native to Ceph. So Ceph has the native RADOS protocol. So if you have a client that can talk the native RADOS protocol, that's the best way to utilize Ceph. Then you can connect these clients directly to the public network. But if you have, for example, SMB or NFS or S3 clients, you need these gateways. These gateways translate the NFS, SMB, or S3 protocol into the native Ceph protocol. And that's why we need them as a man in the middle. And the more clients we have, which I call here other clients, we need more gateways based on the scaling we need for that. Everything here, like the network and the gateways, the monitors, etc., should be set up in a fault-tolerant way. That's why we have here two network switches. Even on the client side, you might have, on the other client side, you might have two network switches. I just didn't put that on that slide because was getting too busy already. So this is basically the architecture overview. The question now is, based on your current environment, based on your requirements, how does this need to be adjusted to your needs? So I believe this is now the first section of this session. So the first 30 minutes are over. So I do 10 minutes break, 10 seconds break, and then I continue with the next slide. Okay, so first of all, after we know how much capacity we need to define how much or how many storage devices do we need, how many spinning disks, SSDs, NVMEs, or whatever type of storage disks, storage devices exist in the future. We had two different formats in the past, how to store the data on these devices. So basically, I just want to tell you, the new one is BlueStore. The old one was FileStore, but we never use FileStore again. This is just for the people that might upgrade. Please go away from FileStore and use BlueStore in the future. And we have to talk about, do you want to use replication, which is basically a RAID 1, and you can define how many copies of something do you want to have. Or we can also use erasure coding. Erasure coding basically is similar to a RAID 5 or RAID 6, where you define in how many chunks you want to split the data and how many checksums you want to have. And then the data is stored, distributed in the cluster. So the examples I'm giving now will just be for replication. Erasure coding is a bit too complex for this slide deck today. But if you have questions for that, just drop me an email and we can discuss it offline. So the first thing we have to figure out is then how many disks do we need for the total system. So first of all, we need to know what capacity we need. And then we need to define what the replication size is. Replication size is basically RAID 1 with the number of copies. And we always have to keep in mind that we should never ever fill up the storage by 100% because that would be a full stop. You will not be able to write anymore. And that's why, as a general rule of thumb, we are adding 20% to the total capacity requirement to be on the safe side. And once we have that total capacity defined, we divide it by the size of the disks we want to use. And based on that, we figure out how many disks we need. So just for an example, if I want to have a 1 petabyte system and I'm doing a replication of 3, I would have 3 petabyte. but then I add 20% additional capacity to be on the safe side. With that, I will have 3.6 petabyte what I need to provide as brutal capacity. And because 8 terabyte disks have just if in case that's the situation, I don't know if that's the current price versus value situation, but if you have, for example, 8 terabytes, you get the cheapest price per terabyte. We select the 8 terabyte disks, and with that we end up in a calculation of 450 disks that we need. So after we know how many disks we need, the next thing is we have to think about what bandwidth and latency requirements we have. And as some rough numbers, basically with spinning disks, HDDs, you get 150 megabytes per second, with SSD 300 megabytes per second, and NVMEs, for example, 2 gig per second. But you always have to check the white papers because there is a lot of variation what you get based on disk type, rotational speed, etc. But what's important is if you have low latency requirements, you have to use flash disks, SSDs or NVMEs. If it's just a big bunch of storage where you only write once and you don't have any performance requirements, you can still stay with HDDs, and as long as you don't have latency requirements. So just keep in mind, for lower latency, use SSD or flash. And for the data we store within Ceph, we have some metadata that we store on a separate area of the system that we call write-ahead log and RocksDB. Basically, that's the database for the metadata of the objects we store in Ceph. And we have the possibility to offload these on separate devices. And we highly recommend to do that. And in that case, when we put NVMEs for the RocksDB of HDDs, we recommend a balance of 1 to 12 if you use NVMEs, or 1 to 4 if you use SSDs, so that we get, for small I/O and for metadata changes, low latency. And for the big I/Os, basically, that does not really matter. So if you put, for example, 24 spinners in one server, we recommend to put at least 2 NVMEs for the RocksDB of these devices into the same server, and configure the system to have RocksDB separated on these NVMEs. For a size of the SSDs or NVMEs, the basic standard recommendation is to start with 64 gigabyte per RocksDB per OSD. So if you have 10 OSDs in one server, the NVMe should be at least 640 gig or more. So that fits. Okay, after we have the number of disks, the next thing is we have to talk about the network infrastructure. Network infrastructure, basically we have 2 technologies today. We have the 10 gig and the 25 gig, which are up to 100 gig. And basically you have to decide which one of the 2 you want to have. With the 10 gig, you get 1 gigabyte per second over one interface. With the 25 gig, 2.5 gigabytes. Normally we recommend 25 gigabit interfaces because that gives us a lower latency due to a higher frequency. For the bandwidth, we have to make sure that the cluster network has more bandwidth than the public network to ensure we don't get a bottleneck on the cluster network. Because when we do a replication by 3, which is the default, we have basically 1 megabyte written in the public network, and we have some write amplification in the cluster network because the cluster needs to create 2 other copies, which is basically the double amount of what's going on in the public network. And that's why we recommend to have the cluster network twice as thick as the public network. For fault tolerance and bandwidth increase, we recommend to use LACP, which allows you to merge or put multiple interfaces in the same trunk and utilize their combined bandwidth. And then when we talk about how many servers do we use and how many disks do we put in each server, we try to balance the bottlenecks and the bandwidth of the disks versus the bandwidth of the network. So just to give you a rough example, if you would put 20 spinner disks with 150 megabytes each in one server, the bandwidth of these disks would be 3 gigabyte. And if you want to transport 3 gigabyte per second over the network, basically you need 3 10 gig interfaces where you have 1 gig on the public side and 2 gig on the cluster side. And based on this calculation, just keep in mind, it does not make much sense to have much more bandwidth of the disks in a server versus what you can transport over the network. So we always try to balance the bottlenecks and the bandwidth within the server versus the bandwidth we have out of the server. Next topic, you always use fault-tolerant switches, which means 2 switches per network at least. You can also combine these switches for public and cluster network and use different VLANs. And just keep in mind that we need cluster network, public network. We might need an administration network. That depends on customer security requirements. We might need an IPMI network for the hardware management. So just keep that in mind when you're designing the network infrastructure. Next topic, how do I size my server and what do I put on which server? So first of all, we have to have the admin server. That's also the one we install first. This is used for monitoring with Grafana and Prometheus, and which is used for administrating the system. Optional, we can put a load balancer for the Ceph dashboard on it, a software-based one. We could also use that as a test client for performance testing. And many customers are deploying the admin server as a VM because you do not really need hardware for this in all the cases. Next step is we have to select the right servers for my hard disks. As I mentioned already, they should be YES certified. We need a specific CPU frequency for the object storage daemons, and just keep in mind, if you're using erasure coding, you need more CPU for the XOR calculation for creating the checksums and splitting the data into small chunks. We need some memory in the servers, so forget about the file store memory, that's not used anymore. And even for BlueStore, we just have to look at the number 2. These days, we just calculate a starting point of 4 gigabyte per object storage daemon plus 2 gigabyte to be on the safe side. And this is basically the standard cache. So we have cache for write and read of 4 gigabyte. And if you have read-intensive applications, you might want to add more memory to have more read cache. Then we always recommend to have SSDs for the operating system, just to have fast installation. And if you do monitor co-location on the same servers, we have to have SSDs anyway. For the number of servers and the number of disks, keep in mind whenever you lose a server or when you lose a disk, you lose capacity. So you still need to have more disks and more capacity that you want to what you need to survive a failure. And normally we also recommend not to pay for RAID controllers because the RAID functionality is basically done by Ceph itself. So instead of investing money in RAID controllers, invest the money in more disks or more memory, more CPU. Other services, monitors, metadata server, etc. Some of them can be co-located, some of them can be standalone. In small environments, we co-locate them, put them on the same servers as the OSDs. And in bigger systems, bigger clusters, we separate them and put them on separate servers. All the monitor manager and metadata servers need public access, public network access. They don't need cluster network. Then we have to talk about which servers do we need for the Raiders gateway, for the iSCSI, NFS, SMB, etc. And we have to clarify, do we need a separate network for the clients, or can we use the public network? We have to talk about load balancer for the S3 access. Do you have a physical one existing, or do you want to have a software-based one? And for the fault tolerance of the NFS and SMB gateway, we have to design a SLI-HA cluster-based solution. So for example, we need 2 servers that provide this gateway as a fault-tolerant access to these services. Okay, so after we have selected the right hardware, the right software, did the right design and architecture, the next step is we have to do we have to deploy the system, and for that I give some recommendations about the deployment best practices. So one standard thing, whatever we do, we document it. So please also keep in mind to document the analysis of the current environment, to document the requirements. Then before we implement, after we have the hardware, etc., we do another review of the design to verify once more if all the requirements are fulfilled with the current design, because between organizing the hardware and implementing it and installing the software later on, some things might not be clarified in detail enough, and we might need to do some adjustments even at this point in time after the hardware is bought, or in the worst case we realize it's the wrong hardware for the requirements. Hopefully that was sorted out before. Then we have to do the hardware installation in the data center. We have to make sure that cabling is correct, network cabling is fault tolerant, etc. We always do apply the latest firmware to the BIOS and network cards, RAID controller, or whatever is in the system. And we standardize the firmware and BIOS settings on all the servers. And while we're in the BIOS, we disable everything that's not required, like serial ports, network boot, power saving, etc. Most important is that all the servers are as identical as possible and have standard settings. Then we set the right hardware date and time. Keep in mind, Linux wants to have UTC. We prepare fault-tolerant time synchronization. So keep in mind, the system requires time synchronization, and if time synchronization is not set up fault-tolerant, it can be a single point of failure for the biggest cluster. We have to take care about name resolution. So all the servers and IP addresses need to be in the DNS system, and all IP addresses have to have unique names, and etc host name should point to the name and the address in the public network of the system. Next level, we prepare the server installation. So whenever we deploy SUSE Enterprise Storage, we prepare a RPM staging system, which can be either SUSE Manager or an SMT server or an RMT server. RMT server doesn't allow staging, but you can stop the mirroring and freeze the patch level with that. And the reason is, when I install one server today and I want to install another server in 2 days, I want to ensure that the other server gets the same patch level as the first level, even if SUSE releases new patches and in the day between. So we always have to have some sort of software staging for production environments. When we install the operating system, we always use BetterFS. We disable firewall, AppArmor, and IPv6. These settings, so this disablement is not really required anymore, but it makes it easier to deploy and configure. So if you don't have these requirements, just disable that. We changed the CPU governor to performance because we don't want to have the CPU frequency being changed dynamically. and we disable the mitigations for Spectre and Meltdown to get most of the performance out of the system. For the server installation, we always use AutoJust, which allows us to have all the servers 100% identically installed, and we have a consulting solution available that makes that pretty easy. So just look up that link and contact me if you need any help for using that. Basically, this allows you to deploy all your servers 100% automated and identical. Then we need some configuration adjustments to the systems. We need some configuration management. Either we can use the salt stack that's part of that we're using in the system anyway, but if you already have some other configuration management, we can also use that one. And if you don't want to use any configuration management, it's also possible to use some template files and just search and replace in that files and copy the files over. But you should really use some sort of configuration management to have a central point of configuration and control amongst the system. So we highly recommend to use Salt. After you have installed all the servers, we always verify if the infrastructure really fulfills all our requirements. So we always verify if all the servers have the right time synchronization. So NTPQ-D or chronic-C sources, that's the command. We verify the name resolution with NSLOOKUP. We check name resolution for each and every IP address and server name, forward and backward. And then at this point in time, before we deploy any object storage daemon, we verify that all the storage devices we have are working properly, are not dead on arrival, and have the same performance metrics. So for all the HDDs, SSDs, or NVMEs in the system that we want to use for OSDs, we do bandwidth and latency tests, also write and read tests, just to make sure that all fulfill the white papers and have the same performance. I've often seen that some of the devices, especially if they're reused, do not deliver the same performance anymore, and that's the first indicator that they are faulty or faulty soon. So we always verify all of them before we're going to use that. That's also true when we expand the system later or when we replace disks. We always verify them before we put data on them. Then one of the biggest challenges I have seen in my experience, we always test all network connections. So it happens over and over again that cables are not connected correct, are not configured for the right VLAN, etc. So I test all the connections. I disconnect cables, I reconnect them, and I use the performance measurement with iPerf to verify the bandwidth and the latency, just to be sure that the whole infrastructure on the network side of things works properly, because before I use SUSE Enterprise Storage, I can test without concurrent traffic, and that's the right point in time to do that. After that, we use the DeepSea framework that we have built to deploy SUSE Enterprise Storage. Basically, that means on the admin server, we install and configure Salt. Then we install DeepSea and set the DeepSea grain, which basically just tags the servers that we want to manage with DeepSea. We can then configure DeepSea, basically how it should control the reboot behavior during patch, and what time synchronization settings it should distribute. Please, please, please never leave the default, which would configure the admin server as the time source, and that would be a single point of failure. And then we just run through the DeepSea stage 0, which prepares the infrastructure, deploys the minimal set of RPMs that we need. Then we execute stage 1, which analyzes the systems. And after that, we configure the policy CFG, which basically defines which components should be deployed on which server that I'm talking to. So which server should be a monitor, which should be a OSD, where would I want to have my Prometheus, Grafana, etc., etc. And then adjust the drive group settings, which is basically the rule. How do you want to deploy your object storage daemons, and where do you want to place your RocksDB and write a headlog, etc. Then we verify if the cluster YAML has the correct settings for the network addressing, and we can adjust that if needed. And we adjust some other settings for Ceph-conf set adjustments, memory usage, S3 gateway ports, SSL settings, etc. And after we have gone through that configuration stage, we tell the system to use that configuration by running through stage 2. Basically, that takes what we have adjusted and sets that in salt, grains, and pillar data. Then we execute DeepSea stage 3, which deploys, creates the cluster, and deploys the object storage daemons on all the disks. After that, we run stage 4, which deploys the gateways. And stage 5 is not really required at that point in time because it would just be there if we change something and want to have a deletion somewhere. And basically after that, the cluster will be up and running. After that, when the cluster is up and running, we have to do some configuration adjustments like the crush map, which defines the cluster hierarchy. How many data centers do I have? Where do I want to have, or where is which server located? We define the placement rules where my data should be located. We adjust existing pools because the defaults that we use during the DeepSea deployment might not fulfill all your requirement. We create some additional pools. We adjust gateway settings, create users on the S3 gateway, whatever, or buckets, create Samba settings, whatever's needed. And then we verify the functionality if whatever we have deployed is really working as we expect. So we do some basic functionality testing with Rados commands, with the dashboard usage. We check if Prometheus and Grafana works and if the gateway is up and running. Okay, last but not least, after we have deployed everything, the most important chapter is the cluster testing, because there is a general rule. If you build a cluster and only what you've tested is going to work if you have, only if you tested your cluster successful, it's really going to work successful. And if you did not find any issues during testing, your testing was not good enough. So for testing, we highly recommend to create a written test plan before you do any testing. And the test plan always is based on the requirement assessment that you have. So for example, if you define a requirement, I want to survive a data center failure, one test in your test plan has to be kill one data center. And for these tests, for each test that you're going to do, you have to define a starting point. What's the cluster status? How much data do you have in the system? Which clients are connected? How much load do you create? Then you have to write down what you want to do during the test, power off data center 1. And you have to write the expected result. So what is your expectation when you run this test? And you have to do the you have to write down what's the expected result, and then when you're executing the test, you have to prepare the starting point, you have to execute the test, you have to document whatever you test with timestamps, and you have to document the test results, and then you compare the test results with your expectations. Sometimes your expectations were wrong, sometimes the system is not set up correct, and sometimes your expectations meet your requirements. And keep in mind, not every test is enough if you do it a single time. Sometimes you have to repeat it multiple times to be sure that it's really working. From a test point of view, you have to do fault tolerance testing because your system has to provide the data in a fault tolerant way. Always, data is the most important thing. And make sure you test with load on the system and then introduce the failures, network side, different failures, different NICs failures, different network failures, etc. Then introduce server and disk failures, kill different services, etc. And after you have done the fault tolerance testing, you have to do some performance testing. Because at this point in time, when nothing is really working on the system, you can create a baseline. And whenever you have an issue later on, you can just rerun the test So for example, if after a patch was applied, the performance doesn't look good anymore, you can just rerun the whole baseline and compare where the performance differences are coming from now. This helps a lot in troubleshooting later on. So create the baseline from the bottom up. So test the low-level disk with the bandwidth and latency. We most often use DD or FIO, etc. Test the network bandwidth. We already did that during the initial implementation phase. Test the latency. Then we test the file system layer if we use file store. So forget about that one. We don't do that anymore. We test the object storage daemon layer, which is basically the tell OSD bench. We can have a look at the Ceph OSD perf. Then we do the RAIDOS layer, read and write benchmarks with the RAIDOS bench utility. We can use RAIDOS block device performance measurements by mapping it and running DD and FIO against that one. We can use iSCSI testing. We can use CephFS testing, always with DD and FIO, and there are several tools for S3 and Swift. Also, and last but not least, you should also test on the application layer. So if the application layer gives you some performance measurements, basically that's what you should also check out. And document all of that so that you can repeat and compare later on. With that, I think I made it to an hour. So this is the Q&A slide. So feel free to send me any messages either during the online system or via this email address. If there are any questions coming up, yeah, drop me an email. I would be happy to reply to you. Thanks for listening. I hope that part of what I was telling you is helping you with your own SUSE Enterprise Storage deployment. And with that, yeah, I close the session now. Thank you very much for your time and have fun and stay healthy.